operations that cost energy. Yeah.
Because they're already there, they're going faster. If they're already there, they're present, and they're not doing anything. But when you need them, you quickly activate it again, close yourself rather than start from scratch.
That's plausible. That's plausible. It's usually the steps and the pathways are regulated well enough so that you wouldn't have something slow limiting you early. But yeah, that's plausible. But usually you see something like this, where the feedback is in the beginning of the pathway, or at some key branch, right? And then you block everything on one side of the branch. We'll see more examples of this.
Is it always referred to as a regulatory site if it inhibits or, I don't think the other word, but basically promotes it to happen as well?
It's a regulatory site if it's not where the active site catalysis is happening, and where something else is binding to either activate or inhibit the enzyme. All right, so ways of regulating. And there's going to be 8 of these. We talked about product inhibition. Okay? Product inhibition means that so much product is built up in the little microcompartment the enzyme's working in, or wherever it is, that it has some affinity for the enzyme because it was formed on it, so it was bound to it. Right? Probably has less affinity than substrate. But if there's enough of it around, or the enzyme is in a compartment where it can build up, some product might feed back and bind, and it'll inhibit it. That's a possible way of regulating an enzyme. It's not a very active thing that the cell does, but could be.
What does the product bind, you're saying? Could it be multiple things?
Binding the enzyme.
Okay, so it's never going to go back and bind. Okay.
If it binds in the active site, then it'll block more substrate. You could think of the product being a competitive inhibitor for the substrate. Availability. Right? This enzyme reaction could be going on inside the mitochondria, an organelle inside the cell, and the concentration of a particular metabolite that it needs, one of its substrates or a cofactor, is low, for example. And then the enzyme will be always subsaturating for that metabolite and won't be able to go very fast. So it'll be down-regulated because it can't get enough of what it needs. And the cell wants that. Right? One of the ways it can activate it is by doing something to the membrane porosity or whatever, and letting that substrate that it needs get in. Then the enzyme goes faster. Right? So availability. Genetic control. Okay? So if you have a gene that codes for the enzyme, the gene has to be transcribed and then translated.